So here we have to just predict the products of these reactions based on the chemistry we have seen in the lab, in the lecture. So this is a ketone, and you're treating this with lithium aluminum hydride. This is in fact acetophenone. So when you treat a ketone with lithium aluminum hydride, you will end up getting the corresponding alcohol. So the product here is simply going to be that. So 1-phenyl ethanol is the product of this reaction. We didn't really discuss this problem. So problem C is again a ketone or a ketone reacting with sodium borohydride, and here the product is again going to be a reduced form of this molecule, which is going to be an alcohol, and you will still have the double bond here intact, and that C double bond O is going to be converted to an OH. Okay. And here we are using Jones reagent, and this is an aldehyde. If you look at the skeletal structure of this molecule, you have a CH2 and then a CHO, which means if you treat this with Jones reagent, you're going to get the corresponding carboxylic acid, which is going to be the phenyl propionic acid, which is 1, 2, 3 propionic acid. On the third carbon you have a phenyl ring. So this is what the product structure is. And here's an example where we saw in the classroom that when you use a strong oxidizing agent like Jones reagent or KMnO4, you will end up oxidizing your alkene. Whereas when you take this compound, which is 1, 2, 3, 4, a butenal, and it could be cis or trans, doesn't make a difference, and treat that with silver oxide, a reagent like Tollens reagent for example, is going to give you an oxidation product which will give you the corresponding carboxylic acid without affecting the double bond here.